Your two goals today is number one, you need to be able to tell the type of gradients. There are only 4. Number 2, calculate the gradient. Ready? Thanks. 2 things to do. So by the end of the session, I'm hoping to some degree, when I ask most of you, which like I did with the other class just then, in session 3, they were able to do definitely skill number 1. So I knew all my students in the class were able to do skill number 1. Skill number 2, as I was walking around, probably about 50%, depending on how many of them truly understood what I was saying. So I'll see where I can get with you all, but I believe number 1's the easiest one. So we're going to make sure we understand that. Now, before we start, we need to understand, well, what is a gradient? Because once you know what a gradient is, you know what to look for, then you know the types, and then how to find it, okay? So starting off, what is a gradient? I want you to write this in. Gradient, by definition, just means how steep a line is. Fill that in. And I'm going to show you logically on Desmos so you can picture what's happening, okay?
Wait, so is Desmos the number calculator?
Desmos is the Google thing calculator. Yeah, that's right. So what we can do now is we're saying gradient is how steep a line is. Now what you see here, this is an equation. For most students, this means nothing. This means nothing to students. They look at it, doesn't make sense. What you take out of it is this. Every time you write, if you went to Desmos, for example, so DSMOS on Google, and you actually type in the equation, you type in y equals, and you just have the letter x. Doesn't matter anything else. Just having the letter x just by itself, you will get a straight line. That's the study. The study of this whole topic is about straight lines. And all you have to do to understand that is, as long as you have x in the equation, that is going to be a straight line. So watch. I'll go to Desmos, like I did for the other class. I go to DSMOS. Google it, and it usually says graphing calculator. I click on it in Google, and it comes up like this. Now, if you type in here, you type y equals, and it doesn't matter how, as long as you just have the letter x in there, you will get a straight line. Now, what's interesting is it doesn't matter what number you attach x with. So the number in front of x, even though you don't see it, what's the number in front of x at the moment? M, but 1. Okay, so even though you don't see it, technically there's a 1 there. So if I press number 1, it shouldn't change anything. See, I put a 1, still the same thing. I want you to see what happens. You can come up with any numbers you want. I can do 2. I can do 3. I can do a fraction. I can do 1 on 5. I can do pi. So I can type pi here. I type pi. It's still a straight line. See that? That's a pi symbol there. So pi in front of x. It doesn't actually matter what you put in front of x. It will still be a straight line. Because the thing in this equation that matters most is the fact that you have an x. You have an x, it's a straight line. As soon as you change that x, you do x squared, x cubed, then it's not a straight line. So for example, if I change this now to x to the power of 2, not a straight line. I do x to the power of 3, not a straight line. But the only way to keep it a straight line is if x to the power of 1 or just x. Okay, so if you just have x, you'll always get a straight line. Now, what we're studying here is we're looking at 2 things that you can do to x. You can either multiply or divide to x, or you can add or subtract to x. That's what the M and C is on your sheet. Okay, so M, if I go, oops, not that one, going back. You see, M is the number in front of x. And when you put a number in front of x, what are you doing to the x?
You're multiplying.
You're multiplying, very good. You're multiplying. So here, you're saying, if I put a number in front of x, it means you're going to times something to it. Plusing, now you can add or subtract another number. Now, no matter what numbers I come up with, and I'm going to show you, I'm going to make up fractions and decimals and all that, and you'll see it's still going to be a straight line. You see, even if I did this, so if I went back, number in front of x, I could do a fraction in front of it. I could do pi, take away roots, how do you do root again? Root of 5 divided by 7, and then minus 1. It's still a straight line. See, I can make it as crazy as it is at the front of x. Doesn't matter. M is just whatever this thing is, this number multiplied by x, it doesn't matter. And then I add or subtract anything you want. I don't even have to do -1. I could have done minus pi. It's still a straight line. See that? So what governs a straight line? It literally is just having an x in it. Obviously at a year 9 level, you're not going to get these kind of numbers. You're actually just going to get a nice number. You're going to get something like this. Instead of minus pi, it could be -1. Instead of this weird fraction, you could get something in year 9 like, or even year 8, it could just be 2. Right? But the point is, whatever number in front of x, doesn't matter. It's a number. Whatever you're adding or subtracting, doesn't matter. But there is a pattern to it. So the first one I'm going to get you to see is what happens when I change the number in front of x. So we start off with 1. Okay? So this is what it looks like. Now tell me what happens when I change it to 2. Then I change it to 3. What's happening? It's getting steeper. So 3 was bigger than 2. So if I go to 4, it's getting steeper. So it's still a straight line, but the number in front of x, the larger I change it. So if I went to 99 now, let's just make it 30. You see how steep that is? And steepness is essentially talking about how, if you were to walk up this hill from left to right, if you were walking up the hill, the larger the number, the steeper it is, the harder it is, right? So the larger the number, if I made 99, that's very steep. It's very difficult to walk up that hill. That's what that number represents. Now, what was the name in the start of this session? What's the name that I gave to you that means steepness of a line? Gradient. So in your notes now, that number that you put in front of x is the name for gradient. Because that's what gradient means. The number in front of x determines the steepness of a line. And what we found just now is that the larger the number that I chose, what happened to the line? It's steeper. So write it in. So that means if I can make a line really steep, meaning going up this hill is going to be really difficult and challenging, so the larger the number, it's steeper, how do you think I can make the line easier, meaning flatter? What do I do? Lower it. So I started off with the gradient of 1 before. The number in front of x was 1 before, right? If I want to lower it, so let's see. Let's go back here. I'm going to put 1. If I want to lower it, a number smaller than 1 is? We can have half. Watch what happens. I put 0.5. See, it's getting slightly a bit longer. Then I go, what's a number smaller than 0.5? Say it again. 0.01. So watch what happens. I go to 0.3, 0.2, 0.1. So that's point, and then 0.01. Whoops. Can you see how it's getting really... Oh, sorry. I have that -1 there. I'm just going to delete that -1. Can you see how it's a lot flatter? Because the number's really small. But then someone here just said another number. What's a number smaller than 0.01?
001.
001, but is -1 smaller than 001? Yes. So watch what happens when I do a -1 now. Now, is this steeper or flatter than the line we just had? So we had this line. We said 0.01. That's 0.01. You told me that -0. Yeah, negative. You said -1 is smaller than 0.01. But what's happened now? Which one's steeper? Yeah, the 0.01 is steeper. So what was that negative? By putting a -1, technically the number or the number line is smaller, yes. But if you look at the value, don't worry about the signs. Ignore the signs. Don't worry if it's positive or negative. If you just look at the number, see that's a 1. That's 0.01. So the number is what matters. The larger the number, the steeper the line. Because 1 is bigger in value, it is steeper. But what did the negative do? Just like, I think it was you. You said, what happened? What is this going?
Downhill.
Downhill.
Yeah.
So the negative makes it go downhill. The positive, see if I change this from a negative to a positive, it goes uphill. So positive goes uphill, negative goes downhill.
So gaining and then you're
Losing, yeah. So you can think of it as you're going negative, this is meant to be easier, less effort, negative, taking off effort. But at some point, it's too hard. If you take off too much, if I went to -10, So negative 19. See, going down a hill is easier. But if you try to go down this type of hill, it gets a bit scarier. And if I asked you to go, imagine snowboarding, and I told you to go down this hill, that's really intense. You're standing at the very top. I'm like, go, jump. It's negative 99 gradients. It should be fine because it's taking off a lot of effort. The problem is, it's getting now, if you were to slide down that hill, you might. Yeah, especially whatever is on the bottom. If it's water, maybe you still die anyway. But the point is, the 99 is a very large number, value. Value-wise, it's a very large number, so it makes it very steep. The negative just tells you which direction. So the positive just tells you you're going up a hill. If you get rid of a negative, very good question. If you take off the negative, it should be uphill. Can you kind of see that slightness?
Yeah.
It's going uphill now, but it's just very steep uphill. So you can have very steep downhill, or you can have a very steep uphill. And what determined that was whether it's positive or negative. Okay? So what makes it flatter then? So if I make the number too large, they get steeper. But the only way to make it smaller was the numbers had to be between 0 and 1. It has to be a fraction. Yeah? So if you want it flatter, it had to be something like 0.1, 0.2. Even if you had a negative version of it, it's still flat. Yeah, it's just downhill, but flat. So the only way to make it flat is it has to be between 0 and 1. Write this down. So to make it smaller the number, the flatter it is, but it has to be between 0 and 1. I'll just write it again. Between 0 and 1. Okay, so if it's between 0 and 1, the gradient will be flat. Okay, it will look flatter. It'll be closer to the x-axis than the vertical axis. Okay, so the larger the number, closer to the vertical axis. The smaller the number, the closer to the x-axis. Okay? The signs, whether it's positive or negative, just determines whether it goes up or goes down. Okay, so you can go uphill or downhill. So far, so good? Yes? All right, so that's what gradient means. So when we look at this and we call that the gradient, all they're just saying is they realize the number in front of x will influence how steep a line is. And we gave it a name. We just call it the gradient. Cool? So, first skill, type of gradients. So all the other students was able to learn it, and I promise you everyone here can learn type of gradients because there's only 4. Here are the 4. You have 1, 2, 3, 4 types of gradients. From left to right, if you're going uphill, we call that positive. Okay, we'll go uphill. It's positive gradient. If from left to right, you're going downhill, we call that negative gradient. Okay? Now, those are the 2 types. Now, there's 4 types in total. So which 2 types of lines am I missing at the moment? What am I missing, Kyle? I got 0 and undefined. Now, what is 0 and undefined? 0 will look like a very flat horizontal line. So it's exactly 0 effort. See, uphill is adding more effort. Downhill is less effort. And then 0, which is no effort. It's flat. I'm okay to walk. Right? So this is called 0 gradient. And the last one, if I can have a horizontal line, then I can also have a vertical line. So the last one is called a vertical line, or which is a gradient that is called undefined. Technically, the way I explain to my students is I say it's impossible. You see, one way is it's positive effort to go uphill. It's less effort, which is negative, to go downhill. 0 effort to walk on a flat ground. But it's impossible to go up vertically unless you can fly. Right? So, instead of saying impossible, it's undefined. Later on, I'll show you why it's impossible to calculate this or why it's not possible to do. But for now, I just want you to memorize that. So uphill is positive, downhill is negative, flat is 0. And if you can't go up, or you can't go up this hill, if I ask you to walk up this wall, you say you can't do it, it's undefined. Walk. I want you to walk. So unless you're Spider-Man, okay, then you probably walk up. All right, so those are your 4 types. So the first skill is I need you to be able to determine the types. You ready? Copy that down? Good? All right, I'm going to test you now. I'm going to call out a couple of students. Here we go. Let's flip over to the exercise. So I'm going to pick this one, B. What type of gradient is this graph showing, or this line showing? Can I please have Lucas? What type of gradient is this? Positive. Very good. So we got positive. That is correct. Let's pick another one. What is this gradient? Can I please, let's go with Leon. Negative. Again, left to right is going downhill. So this is negative. Okay, negative gradient. Let's pick Bo. Let's have a look at, where is it again? There's an example from the textbook. Here, this one. All right. What's A?
0.
0. 0 effort because it's flat. Okay, so it's not less effort. It's not gaining effort. It's flat. So 0 effort. So this is 0. Good. Let's go with the next person. Let's go with Haoxuan. What's C? Negative. Beautiful. So we got negative. That's correct. That is going downhill from left to right. So that's a negative gradient. B, what is that one? Let's go with... Yeah. Positive. Very good. And then last one. Let's go. Undefined. Very good. These are your 4 types. Is that easy? Okay. That's all I need you to do. So that's the first skill. You need to be able to determine the type of gradient by looking at the shape. Okay. Later on, we can actually calculate this. Here we go. Back to your notes. Back to your notes. So we just tested. You got your 4 types of gradients. The second skill is, well, how do you calculate it now? So you know M, which is the number in front of X, will determine the steepness. That number is what you need to figure out from a graph. Okay, so they can either give you, there's 2 ways to calculate a gradient. There's a formula follow, or you can read it through a graph. At the start for year 8, you read from a graph, and then when you get into year 9, you don't have a graph anymore, and you have to learn how to calculate it. Both of which you need to know how to do. Okay, so I'm going to write here, graph and no graph. You have to know how to do it for both. Cool? Good. That's why I want you to copy down. So over here, what Carl just said, I'm going to get you to copy next to gradient. How do you calculate gradient? For graphs, if you have a graph, they call it, all year 9 teachers will always say this. They'll say rise over run. Just copy that down for now. And if you're not using a graph, so I'm going to write underneath, this is for graph. For no graph, we use a formula, which most of you would do intuitively already, but I'm going to get you to copy this formula down. It's called y2 minus y1 divided by x2 minus x1. Just copy that down for now. I remember when I first learnt this when I was in primary school, that was like, what is going on? I had no idea what was going on, but I later then understood what it actually represented, and it makes more sense. But at the start, when you first see it, it looks scary, just because you got letters and numbers mixed up there. Just copy it down for now, and I'll explain what it actually does. Okay, so just copy that down. Rise over run is if you have a graph. If you have no graph, use that. Year 9s will usually move away from this method, rise over run, and they will stick to only this method. So you want to kind of get used to using this formula. Okay? All right, let's do an example. Let's do an example after you copied those notes. Rise over run if you have a graph. If you don't have a graph, y2 minus y1 over x2 minus x1. Here's how it works. Let's do this first example. Example 1. Now let's think about it. A straight line. What was the minimum number of points you needed to sketch a straight line again? 2. You need 2 points. It also means that if you wanted to find the gradient, you need 2 points as well. It's impossible to find with just 1 point. You have to use 2 points to find it. So I can already see 1 point. They've given to us as 1, 3. So I've got 1, 3. I need another point. Can anyone see on the graph a second point that's very clear? Even though they haven't labeled it, it's very clear. Which one is that, Josh? 0, 0. This point right here is hidden. You have to learn to read from a graph there. The line clearly passes through 0, 0. So I now have 2 coordinates. 1, 3, 0, 0. Let's do the graphical method. To find the gradient, if I'm using a graph, it was rise over run. What does this mean? This just means how much up or down, how much left or right. That's it. Nothing else. You're just reading between these 2 points, moving from left to right. How far do you have to go up or down? And how far do you have to go left or right? Obviously, if you're going up, that's positive. Down is negative. If you're going left, it's negative. If you're going right, it's positive. That's all you're going to stick to. So starting from left to right, starting at 0, 0. If I want to get to this point, imagine you're playing a game and you're moving your joystick, or on your laptop, you have to press up, down, left, right arrows. How many arrows do I have to go up or down to get to this level? 3 up. So I have to go 3 up and then
1 right.
1 right. So let's write that in. You said 3 up, 1 right. Now, if it's up, is it positive or negative? Positive or negative? Positive. Every time you're going up. So on the y-axis, if you're going up, it's positive numbers. Right, on the x-axis, it's positive numbers as well. So you have a positive 3 over positive 1. That's why they call it rise over run, because it's how much you go up or down versus left or right. Positive 3 over positive 1. What's positive 3 divided by positive 1? Positive 3. So if I asked you, what is the gradient? What's the steepness of this line? The gradient is 3. Or if you type on Desmos, you type y equals. Now to make sure it's a straight line, what must you have? X. But the number in front of x is the gradient. The number in front of x determines how steep the line's going to be. And you just worked out m has to be 3. So if I type this in, and assuming that I haven't added or subtracted anything, I should actually get this graph, which it is. I can show you on Desmos now. If I went back and I typed in y equals 3x, right? And we said that it should cross at 1, 3. Watch what happens. I put in 1, 3, label it. It does. That's actually the graph that you got here. It crosses through 1, 3. And I've got 1, 3. But how did I do it? We just worked out the gradient. We worked out the number in front of x to make sure I get that steepness that I want. And that's what you did. You just counted how far do I have to go across, how far do I have to go up or down to get between one point to the next point. Does that make sense? So that's the graphical method. Rise over run. Most year 8s, that's what they need to learn first. Enter into year 9. What if you didn't have a graph? Copy this down now. So that was the graphical method. The other method, so let's do it again, brand new again. So underneath, we're going to write the 2 coordinates again. So you need to find 2 coordinates. We said 1, 3, and the other one was 0, 0. Yes? Now let's look at the formula again. What was the formula to find the gradient again? What's the formula? y2 minus y1? x2 minus x1. Beautiful. Now this one looks confusing in terms of the formula, but it's not. This is how easy it is. The 1s and 2s just means first point and second point. So it doesn't matter which one's the first or second. You can name it however you want. So you can say, this is the first point, this is the second, or you can flip it around. Actually, it doesn't matter. This is the x coordinate. This is the y coordinate of the first point. So that's why we say x1, y1, because it's the x coordinate of the first point, y coordinate of the first point. This one is a second coordinate. So therefore, this is x2, y2. But it doesn't matter the labeling. You could have flipped it around and the answer is going to be the same. It actually doesn't matter which one you call first and second. You make it up. Doesn't actually matter. Okay? So I just went with left to right. I called this the first point. That's the second point. So this must be x1, y1. This one must then be x2, y2. According to the formula, you just need to make sure you plug in correctly. Now, funny enough, in year 9, you know what the biggest mistake is? It's not that they don't remember the formula because we give it to them. And it's not the fact that they label it wrong, because you can't label it wrong. You know what they do wrong? Is they put it wrong. They literally, some reason as you're doing this, students will take Y2, put it here, or take Y1 and put it, they just mix it around. Or they put these numbers, which is X and Y, and they put it on the top, they put these two on the bottom. That literally is not just plugging what you see. See, Y2, what number is representing Y2 at the moment? 0. But for whatever reason, sometimes I may get a student puts a 1, puts a 3. But literally, the way I've labeled it right now, Y2 is 0. So what you should actually write is 0, take away, and which one's Y1? 3. So look at it, Y1 is 3. So you then say 0, take away 3, divided by 0, take away 1. Very good. Now, if you struggle with, or you make errors here, then my other recommendation, which I've seen another Year 9 learnt from another teacher, is they just put it vertically. So they just do it like this. They do 1, 3, 0, 0, and that way, this is your X, this is your Y. So they just did 3 take away 0 and 1 take away 0. So that way it's more vertical. So if you like, you can do it that way as well. It's the same thing. As long as you label them X1, Y1, X2, Y2, same thing. You're just subtracting the Y values and you're subtracting the X values. That's all you're doing. Okay, you're just finding the difference. How far horizontally and how far vertically. That's all you're doing. That's what the formula is doing. Yeah? So, let's follow the formula. What does it give me? 0 take away 3. What's 0 take away 3? Negative 3. 0 take away 1. And negative 3 divided by negative 1? Positive 3. That is the same answer that you would have got up here. And it actually doesn't matter if you flip it around. Had I flipped it around, it would have been, instead of 0 take away 3, it would have been 3 take away 0 and 1 take away 0, and you would have got the same answer. It would have been 3 divided by 1. So it doesn't matter which one is 0.1 and which one's 0.2. You can choose whichever you want. Make sense? I want you to have a go. Not with these ones over here, because this has a graph. I want you to try the harder version. Flip over the page. And do this last example. Here we go. Try this one. Tell me what the gradient is. And I prefer that you try not to do it with the graph. Okay? You can plot that onto the graph and then calculate by reading. But I want you to try to calculate this without using the graph. Because the graph is easier. Most students can read the graph. Not many students can calculate. All right? So, here we go. I'm going to give you 2 minutes. I want you to find the gradient using y2 minus y1 over x2 minus x1. Remember, it doesn't matter which one is first point and second point. I'm going to pause the video. Let's see if you got the right answer. So, I would have done 6 take away 2 divided by 1 take away 0. 4 over 1. So, I should have had positive 4. Hands up if you got a gradient of positive 4. Beautiful. If you got it wrong, it means you might have plugged the numbers wrong. And it doesn't matter if you swapped it around. Had I swapped it around, it would have been 2 take away 6 over 0 take away 1. Negative 4 over negative 1 is still 4. So it actually doesn't matter which one's the first point or second. You'll get the same answer. Okay? Obviously, when I choose my points, I like to make sure it's going to end up being positive. So I just look at advance. I just look at the y values and I say which one's bigger, and I make that the first point or second point. Okay? That's it for today's lesson. So you've learned 2 key things. 1 is types of gradients. 2 is how to calculate the gradient either through a graph or through a formula. Ideally, you know both, but if you had to choose one, learn the formula, because this is pretty much what you do mainly in year 9, and a lot of students struggle. For whatever reason, it's just the same rule over and over. Okay, same thing over and over. So practice that, get used to the formula, and that's it. That's chapter 9. Means next week I'm going to do a bit of a quiz, test to see how much you understand of 3 exercises. 9B, 9F, 9G, that's it. 9B, 9F, 9G. Those are the 3 things I'm looking for. Yes.
I'm pretty sure.
No, you're gonna have to use all the rules. This is pretty much rule 7.
Squared to the power of -1 is gonna be
1. When you introduce fractions, it makes it more complicated. I would have just used rule number 4. Rule number 4 is that you just multiply that, right? So it's 6 negative 1 times x negative 2, and then the bottom I will keep it as y cubed divided by.
So you'd rather distribute it.
Yeah, because rule number. I think you need to remember all your 8 rules here, but there's that rule where it's a to the power of n, b to the power of n to the power of p is equal to a n times p, and then b n times p.
Yeah.
So in this case, it was 6 to the power of 1, and this is x squared to the power of negative 1. So I just used that rule, and I just said, well, that's just 6 negative 1, and then that's just b negative 2. So I just followed that rule. So by keeping it without fractions, if you change that to a fraction, it makes it more complicated. So I just keep it like this. And then you're dividing, which means you're going to times the reciprocal. But if you do the same thing again, 2 cubed, and then x cubed on the bottom, and then when you're cubing a square, it becomes y6.
Yeah.
And then from here, I'm just timesing. So I just times the top, times the bottom. Use rule number 1 and 2 to combine the x's and combine the y's.
Yeah, okay.
Okay, but it means that you need to know your 8 rules, index laws, really well. So you have to use all 8 laws to go through that. Wait, did I stop?